Last section of Chapter 4. These topics go beyond the basics of time value of money to deal with situations where the time periods are fractional and how to handle situations where the presented data has non-matching rates and periods. The key rule to remember: the time period for N, IY, and payment must match. And typically it's a case of least common denominator. For example, a mortgage problem states that it's a 20-year mortgage at an annual nominal rate of 6% a year, and you need to find the monthly payment. The least common denominator is months, so N is 20 years times 12, or 240 months. IY is 6% divided by 12, or 0.5% a month. In general, you can't go up. Solving for an annual payment and dividing by 12 will not get the correct result. Here's an example with daily compounding. By law, the rate is quoted as a nominal, or APR. The 11.33463% is compounded daily, so to get the daily rate, you need to divide by 365, which is 0.031054% per day. N is given in days, is 273. The periods on the timeline are days, and the rate is a daily rate. Using the general future value formula, your future value is 108.85. Or using the TVM keys on your calculator, note that you deposited $100, so the present value is negative. Also, be aware that you can perform the computation for the daily rate, and then, with the result displayed, press IY to enter that figure in the TVM key. Consider the TVM keys. PV and FV are always lump sums, so your only concern is which is negative, which is positive. With N, IY, and payment, the time period must match. And with payment, be careful of the sign convention: negative for outflows, positive for inflows. Here's a case where the cash flows occur annually, but the compounding is semi-annually. With a 10% rate compounded semi-annually, the periodic rate is 5%. So the periods on the timeline are 6-month periods. This is an ordinary annuity, but the standard annuity valuation formula can't be used. One solution is to simply future value each cash flow individually and sum them at period 6. Laborious, but it's correct. A second method, and one case where you can go up: convert the 5% semi-annual rate to an EAR. Shown here using the formula, 5% every 6 months is 10.25% annually. The EAR is an annual rate, so you can use it and solve for an ordinary annuity value. By converting to an EAR, the TVM keys can be used to solve for the future value of the annuity in the normal manner. Looking at the same cash flow stream, what is its present value? Again, we can discount each cash flow individually and sum them up, or, as with the future value, we can use the EAR of 10.25 and the TVM keys. Here's our final problem to examine non-matching periods and rates. You have two choices: one presented as a flat amount investment and a return given over a number of days, the other given as a flat rate investment and an APR compounded daily. Well, first, you can convert the APR to a periodic rate and to an EAR for comparison. So how do you go about comparing the two options? Here's the problem shown on a timeline with the daily bank rate shown. There are 3 ways to compare the two options. Basically, will $850 left in the bank result in more or less than $1,000? Compute the present value of the note as its cost. Calculate the implied rate of return on the note, and we'll go through each of these options. Option 1. At the given bank rate, in 456 days, your $850 will grow to $924.97, so the note is a better choice. Here's the calculator solution for the future value of the bank deposit. Option 2 compares the present value of the note to its cost. Simply discount the $1,000 payout back 456 days at the daily bank rate. The result is that the note is worth $918.85, but it's priced at $850, so it's a good deal. And here's the calculator solution for the present value. Finally, compare the EARs of the two options. We already computed the bank EAR at 7%. We can find the EAR of the note in two ways. As shown above, enter the given values in the TVM keys and solve for the implied daily rate, and then convert that to an EAR. Result, $13.89. Alternately, you can use the iConvert function on your calculator. Periods per year is 365. The nominal rate is the daily rate times 365, which is 1301. Note that the daily rate was found on the previous slide. Solve for EFF. Again, the note is a better option. That concludes our time value of money review. The Mind Tap problems will provide further review of this material. If you still don't feel comfortable with your calculator, you might check out the Mind Tap assignments that cover the TI Business Analyst 2. So now on to the Mind Tap assignment problems and your Excel assignment. There are also several video tutorials posted to review the TVM concepts in both the TI Business Analyst 2 Plus and in Excel.